All right, continuing on. Low mass star death, type 1A supernova, page 82 in the workbook. All right, so moving on. Number 10. All right, because this process has such narrow specific parameters, parameters, and therefore specific absolute magnitude. The type 1A supernova is a very, very precise standard candle. Now remember the whole idea of a standard candle. If we know the absolute magnitude, the brightness of a specific object, and we can measure that brightness at different distances, we can correlate that brightness with that distance. The type 1A supernova does this in spades. It is very, very precise, and the thing that drives that precision is the Chandrasekhar limit. 1.4 solar masses, not 1.3, not 1.5, 1.4. Think of it as putting black powder into a cannon. If you put the same load of black powder into that cannon every time, it's going to fire a cannonball the same distance every time. Similarly, that's what's going on here. 1.4 solar masses worth of carbon going into a thermal nuclear meltdown the same way every time is going to produce an explosion with exactly the same brightness every time. That's what allows us to use it as a standard candle. Now, I've been using some terms that I haven't explained thoroughly, so we're going to take a few minutes to go through that. Absolute magnitude. When we talk about absolute magnitude, that is the luminosity of an object as observed from a distance of 10 parsecs. So let me write this down. Absolute magnitude. And parsecs, remember, 1 parsec is 3.26 light years, so in other words, 32.6 light years. The magnitude scale is a bit counterintuitive. Negative values are brighter than positive values. All right, now to put this into some more concrete terms, the apparent magnitude of the sun, Sol, as observed from Earth, is negative 26.7. The full moon on a clear night has an apparent magnitude of negative 13. The human eye can see no further than magnitude +6. Anything dimmer than that, we can't see it. And binoculars can get your range extended up to +10. So Sol has an absolute value, Sol has an absolute magnitude of +4.85. Remember, capital M is absolute. That's getting rather dim. Which means that from a distance of 10 parsecs, 32.6 light years, Sol would be barely visible. Yet, a type 1a supernova would be many times brighter than the full moon, over 1,000 times brighter. So you could read the newspaper at midnight until the radiation killed you. So, there you be. Now, when we continue, we're going to get into the nitty-gritties of the arithmetic of calculating distance based on comparing absolute magnitude with apparent magnitude. So that means you're going to have to get your calculators ready to go and make sure that your calculators can do logarithms. Don't panic. I'll teach you everything you need to know about logarithms just to get through this course. Remember, you cannot use your cell phone because chances are you're watching this on a cell phone, so you need to get a separate calculator to do what we'll be doing in the coming days. So I'll walk you through it, and we'll figure out a way to get homework exchanged back and forth. We're still working on that part, but this will get you started. And keep your eye out for more email from me, and here we go.